So today's lesson has to do with growth and decay, and both are exponential changes. So the good thing is that you have these two formulas and they're fairly easy, but you need to know what to substitute in. So I think we've kind of broken this down pretty well. Here is the growth formula and here's the decay formula. As you can see, this is above, one and above, a whole and above, and this is below. So this is almost like a fraction. It ends up being a decimal or a fraction, and this one becomes a whole number. And I've talked about that before. So the A here that you'll be substituting is the initial amount before measuring that growth or decay. It's your initial amount. R is the growth or decay rate, often as a percent. So they'll say it increased by 25% or decreased. X is the number of times the intervals have passed. So this is, some people might call this a T, but this is an X. Key things. You need to check on the words. So do they mean growth or do they mean decay? Sometimes you can use a percent in your calculator, and some people prefer to put them in as a decimal. And that's how you turn them into a decimal. Percent to decimal. So here's an example. So you have population in 2008. And so this town of Flat Creek had a population of about this much and had a growth. Well, it's already telling us we have a growth. And here's our percentage. So which equation represents the population of Flat Creek? Is it a growth or decay? Well, it specifically said a growth, so we'll circle that. And we're going to write the equation. So the equation says y, we're trying to find y, our initial amount, which was 280,000, go back up to the top, scroll down, so we're using this growth equation, 1 plus, and I'm just going to use 0.85%. I prefer to use the percent key in my calculator. And then X is how many years? Well, I don't know that, so we'll just use X. And there's my equation. Next, it says, according to that equation, what will be the population of Flat Creek in this date? Well, what is the difference between this date and this date here? Hopefully you realize that's 10 years. So the only thing I need to do is change this X to, let's get rid of that X and change it to 10 years. Now let's punch this into the calculator just like I have it and pay close attention. Hopefully you can see this. I'll scoot this over. So 280,000 parentheses 1 plus 0.85. Now this is a percent, so I have to find that on my calculator, and I have to hit the second key and my percent key, which to me is right there, parentheses. The 10 is an exponent, so I'm going to hit that caret key, 10, and there's my answer. So we are talking about people, so I'm going to round this to the whole number. So I'm going to write it, what my calculator says. And then if I need this to be whole, that means no decimal. So this 2 tells my 1 to stay the same. So my answer is going to be, gosh, I ran out of room. I should have moved over. I do not like this at all. So my answer is, hello, I'm going to move it over here. I'm so sorry. That looks awful. 304,731 people. So that is showing that growth. Okay. The next one is talking about a charity. During an economic recession, do you think a recession is a growth or a decay? Hopefully you're saying that it's a decay. That word recession. So the charitable organization found that its donations dropped. There's another decay, decreasing word. Here's my percent per year. Its donations were this. So let's write our equation, and I'm going to go ahead and jump down here because it's already saying after 5 years. So this time we're going to use the decay equation, which is a little bit different. So it says y is equal to my initial amount, which is $390,000, times 1 minus my percent, which is 1.1%, and we know it's going to be after 5 years because that's what this says. So let's punch that into our calculator. And again, we are talking about a charitable organization. Okay, I don't think this part goes with that part, so that was weird. But this makes sense. Okay, so 390,000 parentheses, 1 minus, because it's a decay, 1.1, I'm going to use my percent key, close up that parentheses, caret key because exponent, and put 5. Again, I'm talking about, what am I talking about? Money? So I'm going to round to hundredths. This is money. So I'm going to write the whole thing so you guys can see. I'm getting a glare. So since you're talking about money, you round here. So this 7 is going to tell that 3 to bump up. So I would say it went down to $369,016.74. That's my answer. I'm going to go back up to here. Oh, wait, got it. So these are pretty easy. You just have to follow the formula and decide whether it's a growth or decay. These are one of my favorite things to do. So the third one, where they use exponents, is compound interest. And this one, you do need to have certain words. They use words like semi-annually. You need to know what that means. Or quarterly. Or annually. So annually just means every year, one time per year. Quarterly would be 1/4. Semi-annually is, I did that wrong. This should be 4 times a year. This should be 2 times a year. So make sure you fix that. Hopefully you can see mine. There they are. So semi is like a semi-truck. It's 2 trucks in one. Quarterly, quartet, quad, all those things. A quarter, 1/4 of a dollar, or 4 quarters make $1. Annually is one time. So this needs to be multiplied first before you put in the calculator. Okay, so let's see what we've got. So we're going to find our amount. In college, when Jean May was born, her grandparents invested $1,000 in a fixed rate savings account at a rate of 7% compounded. So that's the word we're looking for our compound interest formula. Quarterly, there's that other word. The money will go to Jean May when she turns 18. So this is when she was born to 18. So now we've got a time. This is going to be her time. To help with her college expenses. What amount of money will Jean May receive from that investment? This is super easy. So the amount that she's going to end up with is her original amount, which is $1,000. You can put amount here. beginning amount. Again, we've got a 1 plus. Our R is our interest rate. And our interest rate, we're going to put a percent. Can you see that? We're going to change that to percent. So we're going to say 7% over N. How many times was that compounded? So that's these words over here. So we said quarterly, so that's 4 times. And then out here is going to be the N number of times times time. So we're going to say 4 times how many years? From born to 18. So that's 18. Okay. Now, this, you would think, oh, we just pop that into our calculator. The only problem is they don't like this in your calculator as an exponent. So you need to solve that first. So let's see what 4 times 18 is. 72. So we're going to change that to 72. We'll do caret key 72. Now we can punch it all in. The great thing about a formula is you just substitute your values, plug figures in here, and your answer arrives. So here we go, 1,000, 1 plus, again I'm going to do 7% divided by 4, parentheses, caret key 72. So how much do you guys think she's going to have just off of $1,000 for 18 years? It's not bad. $3,487, and how many cents is that? 21 cents. That 9 is going to tell that 0 to bump up 1. So 21. Not bad. Okay. Let's try this next one. Again, compound interest. We're going to use the compound formula. You have to know which formulas to choose. So Lucy was 10 years old, so she's 10. Her father invested this much money in a fixed rate savings account, and here's our rate, compounded semi-annually, so that's twice. When Lucy turns 18, the money will help her buy a car. So how much money will she have? So A equals, what is the initial amount that she had? $2,500. 1 plus my percentage rate is 8% divided by the number times a year, which is semi-annually, 2. And over here, we're going to multiply that 2 by our time. So from 10 to 18 is 8 years. So that becomes an exponent of 16. Let's punch this into our calculators. 2,500, parentheses 1 plus 8%, using that percent key, divided by 2. Make sure you have your parentheses. My exponent, we decided, was 16. So she's going to have $4,682.45. Make sure you know how to round. If you have questions about rounding, ask me, because I'd hate for you to do all of this and get it wrong because you did not round correctly. All right, guys, let me know if you have any questions. So you've got 3 formulas. A couple more units before the end of this chapter.